Hello, curious ones out there. Let's take a look at this metal and voltage detector. Let's crack it open, see what's inside, try to understand the circuitry, at least the big picture, and see what we learn from this. Right away we see some components, some capacitors, the buzzer, which makes the sound when you've detected metal or voltage, an LED, the LED which lights when we detected something, and up front a mystery component, which probably does the detection, at least part of the detection anyway. I tried to determine what the ICs are there for, but one of them has no markings. I think they've been removed, and the other one, the big one, has something inscribed on it, but I couldn't find anything on a Google search. Finally, our mystery component is revealed. As we can see, it's just two coils wrapped around the same core. One of them is the emitter coil and the other one is the receiver. And I googled the principle and here's how it works. The circuitry on the main board generates a high enough frequency signal, which when passing through the coil will generate, of course, a varying magnetic field. This magnetic field, when it encounters metallic objects in its path, will change in shape because it will induce in those metallic objects eddy currents, which in turn they will create their own magnetic field, which interferes with the originating field. Thus, we can detect these variations either in the coil that we use to generate it in the first place, either in the secondary coil that we saw that there are two coils. I'm not sure exactly how this works, but the point is the device produces a magnetic field which interacts with objects, and if it encounters metallic objects, these distort the field and we pick up these variations on the secondary coil, I think, and that's how we detect the presence of metals. I've soldered some wires to the two connecting points of each of the coils, so you can take a look at the waveforms on the oscilloscope. Also, of course, I've connected the board to its power source, the two batteries on which it operates. We see here that when I press the button, a sine wave is generated, a signal. It's also attenuated, so it dies down in amplitude with time, trying to capture a relevant part of it. Now, we see that when we bring a metal object close to it, well, apparently nothing changes, but if we look real close, we see the amplitude goes down a bit. Since I'm not satisfied with that, let me bring a bigger metal object. Okay. Now with this one, we see a higher drop in amplitude. Also, an interesting observation, if we start with the metal object already nearby and then we move it away and bring it close again, we see that there's no more beep. So the device, I think, self-calibrates to the initial starting field, and then only variations that are lower than that will trigger the metal detecting threshold. Now let's observe something else. Let's see how often these detection pulses are generated. We'll zoom out and measure the distance between two consecutive pulses. So as we're about to see, it's about 200 milliseconds or 1/5 of a second, so we have about 5 pulses per second. Thus far we've looked at the metal detecting feature and how it works, roughly. The other functionality of this device is voltage detection. That is not performed using the coil, it is performed using this wire. It's a different principle of functionality altogether. So this wire acts basically like an antenna, which catches the 60 Hz signal emitted by the wire. Well, I say sort of like an antenna because at these low frequencies we would need an antenna like to be kilometers long, so it's more like capacitive or inductive coupling from what I've read online. So you capacitively or inductively couple with the circuit that represents the wires in the wall and amplify that weak signal to see if it exists, and if it's beyond the threshold, then that means there are wires nearby. I won't go into the details of how this works. Maybe I'll create a separate video about it once I understand the topic a little better myself.